So let's move ahead to point number 3. Use covering index to reduce RID lookup or row identifier lookup. Now let's try to understand that how this statement will improve our SQL query performance. Now RID lookup or row identifier lookup is basically a physical operator, and this physical operator only comes into existence when there is a non-cluster index created on a table. So if there are no non-cluster indexes created on a table, then RID lookup will not come into picture as such. Now because of RID lookup coming into picture, there is a performance degradation in the SQL query as such. So what we'll do first is we'll first try to understand the concept of non-cluster indexes. Then we will try to understand that how RID lookup physical operator brings down the performance, and then we will see how covering index helps us to reduce the RID lookup performance issue. So let's first try to understand the fundamental of non-cluster indexes. Okay, now before I go ahead and talk about non-cluster indexes, let me clarify one thing. Both cluster index and non-cluster index both use the B tree fundamental to search. So whenever you create a cluster index or a non-cluster index, both of them will always have the root node, the non-leaf node and the leaf node. So the binary tree structure or the B tree structure will always be there. Right, so that's the first important point. Now the biggest difference between clustered and non-cluster index is a leaf node. The leaf node of the cluster index point towards the actual hard disk data. So whenever you see the leaf node of your cluster index, that will be pointing towards the actual data on the hard disk, while the non-cluster index leaf node has a row ID. Now depending on situation, this row ID can point towards different things. So let's try to understand those situations. So situation number 1, if your table doesn't have a cluster index, then this row ID will point towards a heap table. When I say heap table, tables which do not have indexes. So when a table doesn't have indexes, that table is termed as a heap table. So the row ID will point towards the heap table, and let's say that it wants to search this value 5. It will go to the heap table, it will go row by row, and it will locate this row, or it will locate the data. Okay, so that's the first point. Now let's say that you have a cluster index created on a table. Then the row ID of the non-cluster index will point towards the cluster index key, and this index key will be used to search the data. So that's the biggest difference between clustered and non-clustered. In cluster index, the leaf node point towards the actual data, while in non-cluster index, the leaf node has something called as a row identifier, RID. Okay, and this RID points towards the heap table if you do not have any indexes, and it points towards the cluster index key if you have a cluster index. So let's try to demonstrate what we discussed. Here's a simple table I have, customer table, which has customer code, customer name and register date. And this table currently has no indexes. So what I'll do is that I'll just go and add a simple non-cluster index on the customer name. So I've selected the customer name and I've said that this is a non-cluster index. So I'm saying here create as clustered as no. So that means that this index ix_customers is basically a non-clustered index. And let me just save this. And then I have written a simple SQL statement here which basically searches the data by using the customer name. We have just created a non-cluster index on this field only, the customer name. And let me just go and see the SQL plan. Now you can see that in the SQL plan you can see something called as RID lookup heap. Now this RID lookup heap is nothing but what we just discussed. What we said is basically if it is a heap table, that means it doesn't have any kind of indexes, then this row ID will point towards the heap. So that's what exactly it is showing in the SQL plan. And if you see at this moment, our table doesn't have any kind of indexes, any kind of cluster index. It has only one non-cluster index. Now what we'll do is that let's go and create a cluster index. So let's go and create, so I'm creating a cluster index on the customer code and I'm saying this cluster index as yes. So you can see that I've created a cluster index on the customer code column. And let's save this. Now let's go and again see the query plan. Now this time if I see the query plan, you can see that it's pointing towards the cluster index key. So previously it was pointing towards the table scan, but now it is pointing towards the cluster index key. Okay. So we have seen, in actual demonstration that how the query plan changes when you have a non-cluster index without a clustered key on a table and with a clustered key. So where is the problem? Now the problem is this jump, this lookup jump. Now, as we said in the leaf node of non-cluster index actually has a row ID, and this row ID needs to do a jump either to the heap table, or it either needs to do a jump to the cluster index key. Now, this jump requires additional effort, and because of this, any kind of lookups which you see on your query plan like this, the RID lookups which you see on your query plan like this, means that the performance has degraded. So how do we eliminate this? So in other words, how do we eliminate this lookup? Okay, it's either a RID lookup or a key lookup. So let's try to understand this. RID lookup can be eliminated by using something called as covering index. Now there are two ways by which you can create a covering index. One is the composite index and the other one is the include keyword. So let's try to understand that how we can first create a covering index using a composite key. So first let's try to create a covering index using the composite key. Now over here we have a simple select statement, and when I see the query plan over here, you can see that there is a extra lookup which is generated of the cluster index. Now what we will do is let's go to a table and let's go and create the non-cluster index. So we go and we create a non-cluster index on the customer name, right? So one is a customer code which is a cluster index, and the other one is a non-cluster index which is on the customer name. Now in order to create a covering index, what we do is that we include the customer code column inside the non-cluster index. So we create a joint key over here, a composite key. Now the time we create this composite key, okay, I'm seeing this. Now the time we create the composite key, and if you go and again see the plan, now let me just go and see the plan, we can see that the lookup is eliminated and it is directly using the non-cluster index, and there is no jump for getting the data. So from the row ID there is no jump towards the cluster index, and then from the cluster index it goes to the data. The jump is happening directly. The key lookup is completely eliminated, so that increases performance. We have seen two ways of creating covering index. One is we have used the composite keys. We have joined the clustered and the non-clustered keys so that the data of the clustered key is included in the non-clustered key and the lookup is eliminated. The second one is we have used the include keyword. Now include keyword is the best way, or I can say it's the official way of creating covering index. And why? So I have listed on three reasons on the video itself. The first thing is that you cannot create composite index on data types like varchar, max, and etc. So if you have huge data types, you cannot really create a composite index. Second, whenever you create a composite index, the size of the index key increases. So because of this, it impacts the future performance. In the coming up videos, we're going to see that why the index key size impacts the performance. And second is that we have a constraint on the index key. On the composite index key is the size of 900 bytes. So when you join two composite keys, you should ensure that this constraint is followed. So because of these three main reasons, include is the best way of creating covering index. So I hope that you have enjoyed this session, and as we discussed that in this session we talked about point number 3, where we said that using covering index we can reduce the RID lookup, and that will improve performance of your SQL query. In the coming up video, what we'll do is that we'll try to understand why the index key size. So whenever we define index key size, if the size increases, why does it impact performance? That will be point number 4. So stay tuned in this video series, and I hope that you are enjoying this video series, and see you in the coming up video clip.